Okay, so we have already seen how to count solutions of equations like cos x equals to x and cos x equals to x and cos 2x equals to x, right? Today, I want to show something deeper, and that is that why cos 3x equals to x and cos 4x equals to x have the same number of solutions. Okay, so first of all, we will see that the cos 3x itself doesn't have the same number of solutions as cos 2x, okay? But I think the idea student would think that as the frequency increases, that is, I have like, let's say cos of kx and then cos of k plus 1x, that this one probably will have more solutions, but that is not always true. And that is what we are going to see today. Okay, so let's start with cos of 3x equals to x, okay? If you have already seen the previous videos, you know that x has to be between -1 to +1. Okay, all right, and for that, let's try to do for the cos of 3x case, okay? Now, I have this and I already have my domain, okay? And let's say I take my f of x here to be cos of 3x minus x, okay? The first derivative is just -3 sine 3x minus 1, okay? And I put it equal to 0 to count the number of critical points here, okay? So that means my sine 3x has to be equal to -1/3. Okay, now how many times is sine 3x -1/3? Okay, and this is something I hope you know from trigonometry itself, that this happens like exactly 2 times. Exactly 2 solutions when x is -1 to 1. Okay, I will not repeat it here because y cos sine 3x equals to -1/3 has exactly 2 solutions. That's more of a part of a trigonometry rather than the number of solutions, which is what we are focusing on here. Okay, so now that I know that there are exactly 2 solutions, I have to now see the behavior also at the endpoints, right? Endpoints. So what is my f of -1, which is cos of 3 and then minus -1. So that is cos of 3 plus 1, okay? And well, that is greater than 0, okay? And what is my f of 1? F of 1 is cos of 3 minus 1, and this is less than 0. Okay, so we see that the function is starting positive and ending negative, right? So if I say -1, 1, it's starting positive and ending negative. So there is definitely one solution here, okay? The other thing is that I'm kind of not going to do it here, but I will leave it as an exercise for the student, is that if you check that sine 3x equals to -1/3 and you plug in what our f of x is in this, okay, you will see that these 2 critical points are actually lying, one is above the x-axis and one is below x-axis, okay? As a result, if you want to like connect it, it's a bit like this. And you see we have 3 real solutions. And this is the answer to our cos 3x case. Okay, now let's try to do for the cos of 4x equals to x. Okay, again, I know x has to be between -1 to 1, and I say g of x equals to cos of 4x minus x. The first derivative is just -4 sine 4x minus 1. And then I take this to be 0, and I try to find the critical points here. And that is going to be when sine of 4x equals to minus 1 over 4. Okay? And I'm saying my x belongs to minus 1 to 1. Okay? Again, you can plot it, and it's something that people should know from the trigonometry, that this has exactly two solutions again. Okay? And again, the same repeats. Okay? We can check what g of minus 1 is, which is cos 4 plus 1. It is greater than 0. G of plus 1 is, which is cos 4 minus 1, which is less than 0. As a result, again, we are going to see that we have exactly 3 real solutions. Okay, so here is the key lesson from this. It's just by increasing the frequency, by frequency I'm saying if I have like sine kx and sine k plus, I don't know, some k prime x, you see it does not automatically increase the number of solutions. Okay, all right, well, I'm writing it here for sine, but the same applies for the cos because we are studying with cos, so that's just for the sake of consistency. Keep cos kx and cos k plus 1 of x, or k plus 2. It doesn't have to be just k plus 1. Okay, does not automatically increase the number of solutions. What actually increases the number of solutions is the turning points. It is the turning points that decide the number of solutions, okay? And how the function behaves at the endpoint. At the endpoints. Additionally, because we have turning points, again, doesn't mean that we have some solution, because consider something like this. Okay, I have two critical points, one minima, one maxima, but if I have some domain here, I can clearly see I have only one real solution. So we also have to make sure that the turning point is one above x-axis and one below x-axis. Okay, now I'll give you a homework. I think we have done enough in this, so probably you guys should be able to attempt. If you have for cos of nx equals to x, how many real solutions exist? And it is not a very trivial problem because it depends a lot on the value of n, okay? If you want a relatively basic problem, you can try the number of real solutions for this, or we can have several variations of the same. For example, this, okay, or sine 3x equals to x over 7. So you have all these problems that we can do as a takeaway exercise for home. Okay, I hope you guys learned something in this.